In Chapter 16, Electricity, Section 2, we are going to talk about current and voltage. So we talked about what causes electricity, we got those charges moving. So now what's talked about in this section is actually measuring those charges as they are moving through wires. Current is essentially what carries all of this energy in a circuit. Current flows only when there is a difference in energy between two locations. I'm going to show you a picture of that water analogy again, what that means, but the electric current is not going to flow if you do not have a difference in energy between two locations. The unit used to measure electric charge is the ampere, capital A, or otherwise the short version of it is an amp. We often it was named in honor of André Marie Ampere, who was alive in the late 1700s, early 1800s. He was a French physicist that studied electricity and magnetism. And just to give you kind of an idea, a small battery-powered flashlight bulb uses about 1/2 amp of electric current. So an electric current in a battery is also going to flow out of the positive end and return back in at the negative end. And you can see that on both of these pictures here, what's happening out of the positive and then back into the negative. So voltage is a measure of that difference. So I just said you have to have a difference to get that electricity moving, and then how much of a difference there is what we call volts. So the water analogy on the top there that is showing you, like if you didn't have a height difference, you're not going to have water flowing in the pipe, obviously, unless you don't have a pump there. But if you got a height differential, you don't even need a pump, the water's just going to flow through. So no voltage difference, no current's going to flow. As soon as you get a voltage difference, like you see with the battery there, you're going to get current flowing. Also, let's see here. So current is what actually flows and does the work inside the circuit. And also on the bottom there to give you an idea, because we're talking about work, because the current does work, and we've already talked about work this year. 1 volt is equal to 1 amp of current doing 1 joule of work in 1 second. In our homes, the voltage difference is actually 120 volts usually for almost everything that we use, which means each amp of current carries about 120 watts of power. What we can use, a tool that we can use to measure this is called a multimeter, and multimeters actually measure 3 things. They measure current, voltage, and resistance. So that we talked about resistors before, but yeah, we can actually measure that in a circuit too. But multimeters, you can see I put a couple of pictures on the bottom here. They have 2 different leads on them that they're called, and we just make sure that we need to make sure when we put it on whatever we're trying to measure, you can see the picture on the left-hand side there that the multimeter needs to touch each end of the battery. You couldn't put it both on one side because you got to have that difference. The current actually has to run through the whole entire circuit or make a circuit, otherwise you're not going to get the right reading. Batteries, I think we're going to talk more about these later on, but most batteries, this is not all batteries, most batteries, the ones that we're familiar with, like the AA's, 9 volts, D batteries, or even car battery on the bottom there, use actual chemical energy to create that voltage difference between its 2 terminals. So all those chemical reactions that we talked about in semester 1, we just use that to create a voltage difference. Like for example, you can see in the battery here, the chemical compound is on the inside, and then we also have this other battery here. Those are usually full of sulfuric acid. Finally, the last thing this section talks about is just measuring the current in a circuit. So like I said earlier, that current must pass through the meter when it's being measured. So you can't just put it anywhere, you got to line it up properly. When you're using a multimeter, you need to make sure you set the meter to the proper current. There's actually 2 different types of current. AC and DC current. Now you can see where the rock band got their name from. Alternating current and direct current. When we produce power, or when power is made, it is done so using direct current. So like batteries are going to have direct current. When you actually just, let's say you have a solar panel on your house and you're producing power, it's going to produce an indirect current. But everything we use in our house is actually using alternating current. So you can't just take your solar panel and then hook it up to everything in your house. You have to send it through something called an inverter, what actually turns the current into alternating current. So the stuff in our houses use alternating current, but we produce power in direct current form.